Assalamu alaikum guys, welcome to chapter 7.8 and 7.9 lecture. Yes, I'm doing two lessons. Believe it or not, the last couple of lessons is basically a culmination of the entire chapter with a few twists. So chapter 7.8 is extremely easy. It's factoring by grouping, and you've got another situation where it says factor completely. But notice now that we have four terms, right? In the past we've been factoring trinomials, and actually you've already been doing this, but you just don't realize you've been doing it. So here we go. So when you factor by grouping, basically you're cutting the expression in half. You're finding the GCF for the first half, finding the GCF for the second half, and then make sure that the conditions, remember check that the parentheses are the same, and if they are the same, then you can finish the problem off. So the GCF here on this part is x squared. The GCF, since this is positive, 8 and 16, it's a positive 8, okay? So if I'm factoring an x squared, what's x cubed divided by x squared? Leaves you with x, and then 2x squared divided by x squared. The x squareds cancel out, you're left with plus 2. Over here it's a positive 8, so it's plus 8. And then 8x divided by 8 leaves you with an x. And then 16 divided by 8 leaves you with 2. And then what's the condition? Parentheses are the same. So x squared plus 8 and x plus 2. And that's the answer. Okay? So let's try one where you have to deal with the GCF first though. Because although they'll give you the four terms, there might be a GCF that you pull out first or a common factor. So let's take it from there. So let's say that we have 2x to the fourth, and then plus 4x to the third, and then minus 10x squared, and the last one is minus 20x. Now, what are all of these divisible by? Every single term is divisible by 2x, right? Everything is divisible by 2x. All the numbers are divisible by 2, and the maximum number of x's I can pull out is that just one x right there. So 2x is the first one. Now if I rewrite everything, 2x to the fourth divided by 2x leaves me with x cubed. Okay, and then if I have 4x to the third divided by 2x, it leaves me with 2x squared. So positive 2x squared. And then negative 10x squared divided by 2x leaves me with negative 5x. And then negative 20x divided by 2x leaves me with negative 10. And then at this step, remember, divide by half. Think about it. What's the GCF for these two terms? X squared. What's the GCF? Especially since this is negative, it's negative 5. Both numbers are divisible by 5. So don't forget your 2x that you already factored out as a common factor. Start your bracket, and then our GCF on this half is x squared. X cubed divided by x squared is x. 2x squared divided by x is, or x squared is equal to plus 2. Then remember it's a negative 5 over here, parentheses open. Negative 5x divided by negative 5 is a positive x. And then negative divided by negative is positive. 10 divided by 5 is 2. Close your bracket. Are the parentheses the same? Yes. So then final answer here, 2x, x squared minus 5, and then x plus 2. And this is the final answer. Okay? So that's basically 7.8. So it's something that you've been doing. Now let's go to 7.9. 7.9 is a little bit more intense, but you've been doing it already. The only thing is that you haven't been working with more than one situation or more than one scenario going on. So they want you to simplify, and then they also want you to state excluded values. And I'll tell you when we get to that what it means. So state your excluded values. And basically when you're stating the excluded values, they don't want the denominator to ever equal 0. But we'll get to it when we get to it. So let's say that we have y plus 2 over y squared minus 4. Now y plus 2 is already in simplest of form. But the minute I see a minus sign and a binomial, the first thing I'm going to do, I'm going to test if it's one of my patterns. And remember that I test if y squared is a perfect square. Yes, it is. I tested 4 is a perfect square, and it is. So that means that this is the sum difference pattern backwards and forwards, right? So over here, y plus 2 remains the same. On the bottom, this bottom part, y squared minus 4, becomes the sum difference of y and 2. So y plus 2 and y minus 2. Now, you could put parentheses on top. It doesn't matter if you do or not. But the point here is this. First of all, we're dividing. So this term gets canceled by that term. Okay? Both of them cancel each other out because it's division. What's left on the top? The invisible one that you don't see. Okay? So the simplification for this is going to be 1 over y minus 2. Now you can put it in parentheses. You don't have to because there's nothing else going on the bottom. But either way, I'll accept it. So this is your first answer. Now the excluded values means that in any part of the equation, whether before you broke it down or during the breakdown, especially of the denominator, it can never equal 0. Because remember, 0 as a denominator is not a real number. It doesn't exist. So I need to think about this breaking down right here. If I make this 0, what would cause y plus 2 to become 0? Only if that y is negative 2, because negative 2 plus 2 equals 0. So then what I say that y cannot equal negative 2. On the other hand, over here, y minus 2, how can that y minus 2 become 0? Only if this y is a positive 2. So at the same time, y cannot equal 2. So the excluded values are negative 2 and positive 2. So you can write it this way, or you can also say y cannot equal plus minus 2. Either or, it doesn't matter, okay? So the point about excluded values, at any given point, whether here or here, the denominator should never equal 0. So if we test our positive 2, negative 2, right here on the y squared, positive 2 times positive 2 is 4, minus 4 is 0, so it's meeting the condition. If we test the negative 2 times negative 2 is positive 4, minus 4 is 0, so then these two conditions of positive and negative 2 are the excluded values. Okay, let's try another problem. Here we go. What about if we have 15a minus 50 over 10a plus 35. So what I have to think about in each problem, what are my GCFs, right? 15a and 50 both have a common factor of 5, right? So I can factor out a 5, and if I factor out a 5, what happens? 15a divided by 5 gives me 3a. Minus 50 divided by 5 gives me minus 10. On the bottom, 10a and 35 also have a GCF of 5. All right, what's 10a divided by 5? 2a. What is 35 divided by 5? Is 7. Okay, so in this problem right here, remember that our 5's cancel each other out because it's division, right? So our simplification right here is 3a minus 10 on top, 2a plus 7 on the bottom. Now, we cannot let the denominator equal 0, okay? So in this case, how is it that that's going to be 0 at any given point in time, right? So let's say this. On the bottom, you can either do 10a plus 35 or 2a plus 7. This is another way to think about it. 2a plus 7, if I force it to become 0, right? How is it that it can never be 0? Set it up at 0 and then start solving. First thing I need to do is subtract 7 from both sides. I'm left with 2a is equal to negative 7. Divide both sides by 2. A is equal to negative 3.5 or 3.5. So if I put here negative 3.5 times 10, it gives me negative 35. Negative 35 plus 35 is 0. So here, A cannot equal negative 3.5, or if you want to put 3.5. That's the excluded value. All right? So I've got about 3 more examples for you. And I'm hoping you're not finding it too difficult. I think the excluded value is the one that tests us a little bit. But remember, I'm not going to test you on this. The only reason I'm doing these, guys, is so you can have it in your notes for next year, guys. So here we go. Q squared minus 16 over 7Q squared plus 28Q. Okay? So what did I see automatically? A minus sign, right? So I'm going to test Q squared. Is it a perfect square? Yes, it is. Q. Is 16 a perfect square? Yes, it is. So that means that the top, and I'm going to, I guess, write it over here, guys. The top, it's the sum difference. So it's Q plus 4 and Q minus 4. Now on the bottom, I know that everything is divisible by what? Everything is divisible by 7Q, right? So my GCF for the bottom is 7Q. So if I factor out a 7Q, what am I left with? 7Q squared divided by 7Q leaves me with Q. Positive 28Q divided by 7Q leaves me with a plus 4. Okay? So these two, remember this one cancels that one out. So simplification, I'm left on the top with Q minus 4, on the bottom 7Q. So this is my final answer for simplification. Now, I need to look at my denominator, guys. At no point in time can it equal 0. How would this 7Q equal 0? 7 times 0, right, equals 0. So Q, for sure, in this part, cannot equal 0. So Q cannot equal 0. I don't know why I wrote it so ugly, but here we go. Q cannot equal 0. Again, 7 times 0 is 0. So it cannot equal 0, therefore that condition. What about in this part? Q plus 4. What would force Q plus 4 to become 0? Negative 4. So Q cannot equal negative 4. And these are our excluded values. Okay? Let's try another one. We're almost done, guys. 2 more questions. All right, so here we go. Next example, we have 5x squared plus x minus 6, and then x squared minus 1. Okay, so we're going to have to go into factoring this and factoring that based on what we've learned in class. So the first one, we've got the condition of a leading coefficient and the constant. So 5 times negative 6 equals negative 30. So the conditions are what times what equals negative 30. At the same time, when I add them, it equals to a positive 1. And remember, the factors of 30 that equal 1, that have a minimum or maximum of 1, are 5 and 6. And since it's a positive 1, that means my 5 is negative, right? So I'm going to bring my 5x squared down. So 5x squared minus 5x plus 6x, and then bring the minus 6 down. And remember, we're doing the grouping. What's our GCF here? 5x. What's our GCF here? Positive 6. So this means 5x. And then when I start dividing, 5x squared divided by 5x leaves me with x. Negative 5x divided by 5x is negative 1. I factored out a 6, so it's plus 6. 6x divided by 6 is x. Negative 6 divided by positive 6 is negative 1. Before I finish, are my parentheses the same? Yes, they are. So one of my factors is 5x plus 6. The other factor is x minus 1. So for this one right here, and I'm going to erase this condition just so I have enough room on the board. So for this condition right here, let me draw a line here so it doesn't mess it up or mix it up in between. So on the top, I have 5x plus 6 as one of my factors, and x minus 1. Now this x squared minus 1, right? I see a minus sign. What's the first thing I'm going to do? Test and see if they're perfect squares. And they are. X squared, square root of x squared is x, square root of 1 is 1. So that is the sum and difference, right? So one of my factors is x plus 1, the other one is x minus 1. Both of these cancel each other out. So simplification-wise, I have 5x plus 6 left on the top, x plus 1 on the bottom. That's my simplification. But what about my denominator, guys? Remember my excluded values. This will become 0 if it's negative 1. This will become 0 if it's positive 1. So my excluded values are x cannot equal positive or negative 1. Okay? So you're always looking at the denominator if it equals 0 or not. Now, let's go to the last one. Now, this one actually is in your textbook. And it does happen like this. Will I test you on this? Absolutely not. But I want you to know how to change expressions, especially when it doesn't look like it's going to work out. So textbook page 307, and this is question number 12. All right, so you have 4 minus w over w squared minus 8w plus 16. Okay, I'm going to go to one of my patterns. Whenever I see perfect squares, remember, w squared is w, and then 16 is 4. Since this is a negative, remember that we test negative 2 times w times 4 equals negative 8w. And if it worked out to be the middle term, which one of the expressions is it? It is the perfect square, right? So in this case, on the bottom, we can say, since that's, what do you call it, a minus sign, y minus 4 squared over, or rather under, 4 minus w. Now, what does that mean? So I'm going to erase this because I need the board, guys, but this was just a testing just to make sure that we know that it is making the middle term. So what this means basically, guys, on the bottom, we can spread it out and say w minus 4, w minus 4, because that's what w minus 4 squared means. Here, we can switch it around, switch the expression around, and write it as negative w plus 4. But still, nothing cancels out because they're not written in the exact format. So what I want to do is I want to go ahead and factor out a negative 1. So if I divide everything by negative 1, now you can either divide it or multiply by negative 1, but I'm just going to say I'm going to deal with a negative 1 here, and I'm going to go ahead and basically spread it and distribute it. But I have to keep track of the fact that I did that negative. So my negative is there. Now what happened to my expression when I divided by a negative 1? It went ahead and converted that negative w to a positive w, that positive 4 to a negative 4, and now I can write w minus 4, w minus 4, and remember that I had that negative 1, the invisible 1 is right there. These cancel each other out. What am I left with as my answer? Negative 1 on the top, but it's a neutral negative, negative 1 over w over 4. So here is my simplification. Now, what about the excluding of the zeros, right? So how, since the denominator are w minus 4 on both parts, how can this not equal 0 is if w is 4. So w cannot equal 4. So my excluded value, and I don't know if y'all can see it, w cannot equal to 4, so that's the second answer. So that's it, guys, and that's as hard as it gets, inshallah. If you have any questions, don't hesitate to come to class, but here are the lectures, and stop it, rewind it a little bit, go over it, and just make sure that you have it in your notes so you don't lose your notes for next year and the following year after that. So inshallah you found it easy, and this is the last of chapter 7, alhamdulillah. So we're going to feed off into chapter 8. What have we been doing that applies to chapter 8, and we'll get that to that when we cross that bridge, inshallah. See you in class. Assalamu alaikum.